please ask your friend to join our class. Okay, today we will start. We will continue on the topic cable, which is we stop. I think we stop at here lah. Okay, we last class we stop on MI cable, right? So which is we discuss on MI cable, which is just used for especially for the generator set. So today we will continue topic on still under cable selection and wiring system. So which is I believe that this is the most important part in our subject, which is this is more related to what you have designed on your project also lah. And this is very important part lah. You need to understand in order to make sure your project is correct, and also you can use it this information or this syllabus for your works next time lah. Okay. Right, before that just to update related on your assignment. Assignment 1, I received all of group, but still under marking. But most of the group are not following the rubric marking. But since that's my mistake, because I don't upload the rubric earlier, so I try to help all of you in order to get some marks for your project on under assignment 1. I try to find which part that can contribute some mark for your project. And then for assignment 2 up to 5, please make sure that you prepare your assignment based on the rubric that uploaded to you. Okay, for assignment 2, the printing, because I heard most of you are printing the A3 drawing on at a shop outside Unimap, right? With a price 2.5 ringgit kan. So we have also the photostat machine at lab, so you can use it. You can print by your own. Just make sure you deal with our technician lah, either Puan Najihah or Puan Sheila. So you just pay them RM 1 ringgit per pages lah. So which is murah lagi lah, cheaper than outside lah kan. So and then make sure also at least 3 dB per floor. Okay, and then for assignment 3, after you submit your assignment 2, which is 30 May, so I will upload the new assignment which is assignment 3, which is related on topic schematic diagram. And then after that you will start on assignment 4, which is cable and substation. So now we are on week 9. So as I mentioned, we try to schedule that our presentation will start on week 10. So the schedule still under construction, and I'm still discussing with Mr. Hasnizam related to when the exact date that we want to start your presentation. So the link for schedule I'm still not upload yet. So wait for that. So ada siapa-siapa nak request tak? Nak present dulu? Kalau ada beritahu awal, senang saya. Easy for me to make a timetable for presentation. Okay. So that's all some update related to our subject. Okay, now we start on the topic of cable. So today I will try my best to complete this topic under cable, which is actually cable should be start this week and next week. But since group with Mr. Hasnizam already very fast, they are already on earning topic, so I try to follow him. Okay, so the installation, we need to understand the type of installation of the cable, because when we design the cable, so one of the criteria that we must consider during the design is what the type of installation of cable. As we already seen on during our lab 3, right? The method of the installation, we have 4 to 5 type, right? So which one we want to select, okay, and suit to our design. Okay, so whatever is, we must compliant with the IE regulation 131-.2.1. Okay. And then it said also PVC insulated and sheeted wiring system are used extensively for lighting and socket for this domestic dwelling. So normally we just use PVC for normal wiring, which is for lighting and socket for your project lah. Then if you want to use the XLPE for lighting, I think you are on wrong design lah, because even you can put it, but in real life you cannot use it, because the XLPE is very hard to make a termination to the lighting and the socket. And then the mechanical damage to the cable caused by impact, abrasion, penetration, compression or tension must be minimized during the installation. So you need to consider all of this damage for your design. The cable are generally fit using plastic clip. Okay, that one including of the what we call it conduit. After this, we try to cover. And then the cable should be run horizontal or vertical only, not diagonally down a wall. Maksudnya you need to design your cable for your project or real project. You must be either horizontal, directly straight away, and then vertical. Tu saja. Not diagonal ni maksudnya sengit lah, merata kan. And even normally you can find it on a site, real site. Most of the contractor perform diagonally itulah. Sengit lah kau tu. Dia main tarik je. Tak ikut pun. So kita tahulah yang tu bukan student saya lah yang buat macam tu. Ataupun kontraktor yang tak belajar konsep wiring yang betul. Okay. And then the cable is run straight and neatly between clip fixed at equal distance. Normally we fix at equal distance, no? So because we are referring to the regulation 522.8.4 and also on the table 4A under on-site guide. This one you can download also lah, on-site guide, because under the books IE regulation that I provide to you is not included of the on-site guide lah. So you need to download to another chapter. And then the radius of the band should not cause the conductor to be damaged. Okay, so bending cable, so you need make sure lah, normally 45, and kalau let's say you bend up to 90%, 90 degree, so the conductor of the cable is not good anymore lah. Okay, and for it can withstand for a long time, and sometimes if you measure or you scan by thermal imager, you can find that there are hot spot there at bend. So normally the fault come at that location. So that's why you are suggested, you are okay to design bending of cable not to up to 90 degree. Okay. Okay, a little bit theory under installation. Most of them just information that you need to remember, because this one we just absorb from the whole topic under IE regulation tu. I believe that you all tak baca pun buku yang tebal tu kan. So Kalau you rajin, kami tarik this some part of important part from that book. Okay, and then termination or joint in the cable may be made in shielding rows. Okay, you need to use a shielding rows or junction box or behind socket switch provided they enclosed in the ignitable material. Okay, you can refer to the IE regulation page 5 to 6. And then all joint must be accessible for inspection test. So which is this one, all joint, which is let's say you now pula. Saya try buka kod ada picture. Okay, joint. Okay, if you can see from the figure, this sample of jointing box lah. Maksud dia kalau you ada buat jointing cable di tengah-tengah kan, ada bersambung. So you cannot put it on the direct conduit or trunking. So you must make sure that under jointing tu must provide with the macam ni lah bentuk dah, conduit junction box we call it. Okay, so for easy measurement and also what we call it inspection testing. Senang tengok tu. And then the provide it also must be provide with box incorporate and earth terminal at each outlet position. So earth terminal ni earth terminal look like this lah. Dia ada earth terminal. And then for all load also you will find earth terminal. Even DB pun you akan jumpa nanti earth terminal. So make sure you perform the earth terminal. Okay. Okay, ni contoh this example earth terminal. Kalau dalam DB macam ni earth terminal. Okay, main earth. Kalau dalam socket dia ada tempat dia kan, yang tempat termination hijau tu, kabel hijau tu. Alright. And then what we call PVC cable do not react chemically with plaster, okay, as the do some cable and consequently PVC cable may be buried under plaster. Okay, that's why we suggest to use the what we call it, conduit. Okay, further protection by channel or conduit is only necessary outside of the design zone. Okay, yang ni tak ada masalah. And then PVC cable are to be embedded in wet plaster. Ni kalau nak embedded in wet plaster should be covered in mechanical protection. So it said that mechanical protection kan. So normally nak senang we provide the conduit lah, senang. And then outside zone, mana dia? Outside zone formed by 150 mm border round wall edge, cable can be run horizontally. Okay. And then the rest is the whole should be made good with incombustible material as mortar. Yang ni cara dia nak buat apa? Lubang kan, laluan untuk kabel tu. And then cable passing through metal box should be bushed with a rubber grommet. Contoh kat hujung besi kan. Okay, hujung besi. So we must put we call it rubber grommet lah. That one yang tu dia tak nak bagi kabel luka. Kan kalau kat hujung besi tu selalu dia tajam kan. So sekejap ada contoh picture kot. Rubber grommet. Okay. So this sample of rubber grommet lah. So normally at the end kalau kita tebuk lubang, kemudian we need to put this rubber grommet in order to make sure our cable is safety lah from the end of bucu yang tajam. That's the function of the rubber grommet. And then apa lagi? Sampai mana tu ya? Hilang lah. Okay. PVC cable should not be installed when surround temperature is below. Okay, yang ni kena tengok juga lah. If your project is under area with below 0 degree Celsius, so PVC type cable is not suitable to use because you can see from the data sheet pun it will tell us the ambient temperature for the PVC cable type. So normally 30 degree and above. So kalau 0 degree meaning that kabel ni takkan boleh tahan. So normally dia akan, kalau istilah dia tu dia panggil brittle lah. Brittle tu dia rapuh. Ayat bahasa Melayu dia rapuh. Okay. And then yang ni satu lagi ni, flow joist through which cable are run should be 50 mm below the top or 50 mm above the bottom. Maksudnya kalau kita letak apa-apa paku yang melekat tu untuk pegang kabel tu, make sure dia tak melepasi kawasan tu lah. Macam paku dia lebih kan. Itu maksud dia yang tu lah. Tetap lubang yang kita drill kat floor tu, katakan which cable are run, kalau kita tak nak, nanti dia akan mengganggu, akan bagi kabel lain luka. Itu function dia. And then this is the general cable. So which is you can see from the figure, this is some example of cable lah. I believe that most of you, this is sample of a solid single core. Ini kita punya single core lah, solid. So dia ada simple je, dia ada conductor insulation PVC and then outer sheet. Yang ni pun yang multi core biasa yang selalu you all jumpa juga masa you nak install you punya apa extension and so on. And then dia ada live, neutral, earth kan. Dia ada 3 tu. So it have conductor insulation, cover and outer sheet. Okay ni lah, ada macam paper tu. And then some type cable dia still multi core, it have a live, neutral and earth, but there's some expensive, which is it provide one core for mechanical stability. Dia ada macam dawai kat tengah-tengah tu. So this one for easy installation dan dia punya cable nampak straight elok lah nanti. That one. And then this is another type cable, which is this is PVC, still PVC. Yang ni dia guna underground lah, type of underground, which is yang this one is for SLPE. Okay, SLPE yang label yang ketiga ni. So this is sample. Kalau you nampak macam putih-putih tu kan, atau putih keras tu, that one is SLPE lah kalau kita nak tengok tu. So that the best insulator can be used for cable. Normally we use SLPE for underground cable. Okay, and then this is some also PVC SLPE. This one, this multi-core SLPE is normally used but that one is too expensive because if you can see from this spec, it have a lot of layer, including of banyak insulator lah. Kalau you tengok kan, ada 10 level. So including of conductor kat sini ya, kita punya this is our conductor, but we have a lot of layer, including of inner conductor, insulator, SLP, outer, kemudian dia ada conductive tape, kemudian dia ada shielding, kemudian dia ada conductive copper tape, covering, plastic film and outer sheet. So this is a very good cable lah. Okay, so settle on the type of cable that just to intro to all of you lah, the type of cable that you can use it during your installation design. So normally this type of cable you can use for installation from sub switchboard SSB to MSB normally. Okay, and then the normal cable ni we use for indoor punya installation lah, macam DB daripada DB to the load, from load to DB, and then from to DB to DB or DB to SSB. Normally internal kan, so we provide we just use a PVC cable. Okay, now we try to discuss little bit on installation, which is when we have cable, so where to put the cable during the installation. So normally we try to put it with the 3 type lah, which is number 1 is conduit, number 2 we use trunking, and number 3 we use cable tray. That's a normal installation that we're dealing with the cable. Okay, so now we discuss a little bit on the conduit first. So conduit is a tube, channel or pipe in which insulated conductor are contained. So the conduit in effect replace the PVC outer sheet of cable. And tadi cable tadi ada outer sheet kan. So we can also replace lah kalau kita nak gunakan. And then conduit installation can be rewired easily or alter at any time compare yang lain lah kan, sebab dia PVC, so it is easy for alter kan, kita nak potong pun senang lah. Couple mechanical protection makes conduit installation popular for commercial and industrial application. If you can see, most of the project right now we are using the conduit lah kan. So conduit pula it have 3 type, which is steel, PVC and flexible. So under project government, JKR encourage all of the contractor to use steel conduit, which is project mana yang conduit yang which is want to bury yang nak tanam di dinding tu on wall, so they must use the steel kalau ikut JKR lah. So and sometimes they also can use the flexible flexible PVC yang putih tu. So now we try to check one by one lah. So this is the figure sample of the steel conduit. So it is made to a spec defined by BS 4568 and as a heavy gauge welded or solid drawn. So it made from a sheet or steel welded along the stem to form a tube and issue for most installation work. So solid drawn conduit is seamless tube, which is much more expensive. And then and only used for special gas type, explosion proof or flame proof installation. Tapi JKR suruh guna kan. So kita follow lah. Because normally contractor are not happy with this conduit because it hard to bend and to cut it kan. So it require a lot of energy. And then conduit is supplied with 3.75 meter, is standard size lah, standard line. And normally it's come with typical size yang available at market, which is 16, 20, 25 and 32 mm only. So if you want to design with the different size, so you need to deal with the factory lah. And so that's why we need to design our conduit based on the normal size for our installation design. So conduit tubing and fitting are supplied in a black enamel finish for internal use or hot galvanized finishing on external dam installation. Okay, a wide range of fitting are available and conduit fits using saddle or pipe hook. So yang ni bila kita nak lekatkan our conduit yang steel ni, so you need to use saddle or we call it pipe hook. Okay, this is sample of figure that accessory dia lah when we dealing with the steel conduit lah. So you must use bags, outlet box, ni di saddle yang clip, dia nak lekatkan, dia nak pegang our conduit tu, we call it saddle. Okay, so metal conduit are treated with stock and dies and bend using special bending machine. So you nak bend dia, nak bengkokkan dia, kamu kena ada panggil itulah yang ada kat lab kita tu, bending, conduit bending, conduit bender. Kalau you boleh bend dengan tangan kamu kalau kamu kuat lah. So metal conduit is also utilized as the circuit protective conductor, and therefore all connection must be screwed up tightly and be removed so that cable will not be damaged as drawn into the conduit kan. So before we install the cable, we need to install the conduit first. So based on that, we must install the conduit with the proper condition and use a proper accessories. This one is pipe hook lah. So we put saddle and we put hook and so on. Okay, so this is some important point when we dealing with steel conduit. So when we deal with the steel conduit, then our cable is AC, right? It's a skirt, and we must put on the conduit is cable phase and neutral due to prevent the eddy current flowing. Because if we are just put on phase cable, so the eddy current will combine and bigger, and when we have a lot of eddy current, so they will come the another issue, which is the conduit will become hotter, and because this is steel, okay, when hot, so the cable insulation will not and cannot stand for longer time. Okay, and then this is the PVC conduit. So I believe that most of you have seen this PVC conduit with white color lah. Okay, so normally typical electrical insulation is heavy gauge impact to be manufactured to standard BS 46007. So after this, kalau you nak pergi check tu ataupun you nak beli conduit, you just check dia ada standard, dia label dekat conduit tu. You just check is it fulfilled under standard BS 46707. Kalau it's not stamped with that label, so meaning that you cannot use that conduit. Okay, so the size is same with either PVC or steel, same. And then PVC conduit is most often joined by placing the end conduit into the appropriate fitting and fixing with PVC solvent adhesive. And then PVC conduit can be bent by using hand. Senang je ni. Kalau you nak bend guna tangan memang boleh, tak ada masalah. You just put some spring in spring bender kita panggil, kita letak kat dalam tu, kemudian kita just bengkokkan je, so dia akan dapat very good shape depend on whatever degree that we want. So is it more easier compared to the steel conduit lah. And then this is the little bit on the cara nak bend dia sajalah. Okay, the advantages of a PVC conduit system are that it may be installed much more quickly than steel. Betul lah, sebab nak potong, nak bend yang PVC yang steel kan sangat susah. So that's why most of the contractor will choose this PVC. And the another thing is dia pun tak karat, non-corrosive compared to the steel conduit kan. And then but it does not have the mechanical strength of steel conduit. Okay, lastly is the flexible conduit. Flexible conduit, as you can see this figure dah, dia lembut Itu flexible, nama flexible. And normally we just what we call it, it's made of interlinked metal spiral often covered with PVC sleeving. Then the tubing must not rely. Yang ni we just use the flexible cable during at the condition ataupun kenapa saya punya ni left Okay, yang semua okay, yang line okay ya. Risau saya cakap sorang-sorang pula. Alright, continue. Okay, and then normally we use this flexible cable ni last point, let's say for conduit, from conduit to the lamp, last point kan. So kita pasanglah apa nama dia flexible ni untuk wire kita tu. Kalau tak nanti dia nampak wire saja tak cantik. And also for safety lah kan. For the last one, let's say you have a ceiling, daripada ceiling tu nak turun ke lampu kan. So we just put the flexible ni. And then some part macam you nak crosskan di antara beam yang building yang tinggi besar tu, semen tinggi tu. So sometimes you can use this one, the flexible, and then kalau you tak nak bend banyak kali lah apa conduit tu, kan. Alright. So how we need to determine the conduit capacity, kan. So single PVC insulated are usually drawn into install conduit to complete the installation, having decide upon the type, size and number of cable required for final skirt. And it is necessary to select appropriate size of conduit to accommodate those cable lah. So kita kena tahu lah berapa kabel yang boleh masuk dalam sesuatu conduit tu. Kita tak boleh main hentam je letak. Kalau you buat macam tu, one the issue is during the installation you cannot put all of the cable into one conduit, and the another issue is ruang kelegaan dalam conduit. If you put a more cable into one conduit, so the cable will be hot and hotter, and sometimes it will cause the cable fired lah. So that's the issue. So you must design clearly in order to make sure for safety of your design. So when we're dealing with the determining of the size of conduit, so we are referring to the 4 table, including of 5A, B, C and D. So A is for straight conduit, B is straight run of conduit less than 3 meter, C cable in conduit with incorporate bend, dia ada bengkok sikit, kita ada bending 2-3. And then 5D for conduit run in excess of 3 meter or incorporate bending. Okay, so kita boleh guna tu, table tu. And then this is the sample of the table lah. Okay, this is table 4A, 5A, 5B, 5C dan juga 5D lah. And then based on that, normally we use 5D lah. So okay, we try one example in order to easy understanding on how to determine the cable ataupun the size of the conduit. So let's say we have 6 2.5 mm of PVC insulated cable. So okay, to be run into a conduit contain of 2 band. Nampak mention dia ada 2 band, maksudnya 2 bending ya, 2 yang kita line kita bengkokkan tu. Between 10 meter. So we need to determine the minimum size of conduit lah. Kan kita ada 10 kabel, 10. Kita ada 6 kabel size 2.5 mm. Okay, so macam mana kita nak cari? Kalau kita tak belajar ni, kamu confirm tak tahu lah, kamu main hodah ya kan. Kamu main bubuh je dalam conduit tu. So itu yang berlaku masalah tu. So it was very easy. Firstly, we determine the factor for 2.5 mm. So dia kata ada band kan, ada 2 band kan. So kita tengok table 5C. Okay, sebab dia kata ada bending, so kita kena refer table 5C lah. And then the size cable dia bagi 2.5 kan, 2.5. So cable factor dia adalah 30 kan. Mana dia? Okay, we refer to this one. So 2.5 equal to 30. Okay, then dia cakap apa lagi? Kemudian dia bagi tahu kita we have 6. So we just use 30 cable factor ni multiply dengan multiply with 6 number of cable. Okay, number cable multiply with the factor. So 30 multiply by 6 we got 180 lah. So from 180 we can check from table 5D. Kan? So we have 180. So 180. So kita check lah. So kita tahu kita ada 2 band kan. So this 2 band. And then kita carilah yang mana yang sesuai. size apa. Kemudian kita nak tengok kabel horizontal dia kan. So we do not know which one. So we check our cable how many meter. So from the question, dia bagi tadi berapa meter? Saya lupa. Ni 10 meter. So it told me that it require 10 meter. So since it's 10 meter, so we refer at 10 meter size cable, length of cable to bend 180 tadi kan. So kita calculate, we got 180. So kita tengoklah, so yang ni tak boleh. So 141 pun tak boleh. So 260 is accepted lah. Kan? Sebab dia 180. So and then from there kita tengoklah. So we can find the size for conduit. We find it is 25 mm size dia. Betul tak? So okay. 25 mm. So senang kan? So it's very easy lah if you understand on how to select. Sekali tengok dah tahu lah. Yang the second part ni, second example you can try by your own lah. Sama je, konsep dia sama je. So, let's say you have 10. This one it have a lot of size. Dia ada banyak size kan. So sama juga, you cari cable factor dulu untuk cable 1 mm berapa, 4 mm berapa, you dapat lah factor dia. Kemudian you just plus. Okay, factor tu berapa, then you dapat nilai dia, and then you check dalam, you dah ada panjang ni berapa kan, dia bagi berapa meter, from how many meter tu, you check dalam table. So you akan dapat terus je size berapa yang sesuai. Okay, so and then we go to the another type which is trunking installation. Tadi conduit yang bulat tu. So trunking ni yang bentuk orange tu. Macam ni, mana bentuk dia. Ni lebih kurang macam ni lah. Tak ada pula Kamu tahu tak trunking tu macam mana? Saya harap kamu tahu lah. Kita tolong Google lah kat apa. Apa ni risau juga. Saya ingat tahu-tahu lah, tak tahu. Trunking. Ni untuk orange ni. Ni. Kan? Selalu nampak kan orang letak wire kat dalam tu. Ni dalam ni. Orang letak wire dalam tu, trunking. Normally orange lah. Okay. Kita akan letak trunking ni lalu angkat atas bumbung macam ni. Okay. Macam ni. Trunking wiring. Nampak? Ni orang letak ni. So wiring semua letak kat sini kat atas ni. So jangan keliru. You don't confuse with red color. Red color is for bomba service. Okay. White color for ICT service. So orange color for electrical service. Okay dah? Clear? So when you want to put the electrical, you just put on this one lah, dalam trunking. Okay. Now you can see here. So green, white and orange. Orange is for electrical, ICT. Green for, siapa boleh jawab? Hijau untuk apa? So hidup ayah. Siapa boleh jawab? Hijau untuk apa? Servis apa? Semua tak tahu? Okay. Hijau untuk telefon. Servis telefon. So kalau kamu design telefon nanti dalam building tu, you tak boleh combine dalam satu trunking tu. Kan? Especially telefon lah. Telefon. And then ICT dengan telefon pun tak boleh combine. So ICT put dalam yang trunking putih. Yang combine elektrik dengan ICT pula. Jahanam lebih. Okay. So trunking installation is an enclosure provide for the protection of cable, which is normally square or rectangular, bentuk dia rectangular kan. So trunking may be tough of a more accessible conduit system, sebab selalunya kita pakai conduit ni untuk kabel yang banyak lah. Okay. Alright, metallic trunking is formed from mild steel sheet. Besi lah, coated with grey or silver enamel paint for internal use or hot dip galvanized coating. So wide range of accessories are available such as 45-degree bend, 90-degree bend, T and 4 junction. So dia nak bending tu kan, dia dah ada jual aksesori dah. Sebelum ni kita we need to cut by own to bend it to become 45-degree or 90-degree. But right now we can buy it lah because a lot of accessories are available. And then when fabricating band, the trunking should be support with wooden block, yeah, from sewing and filling. And then the size of protective conductor will be determined by the largest cable contained in the trunking as described. Sama juga lah. So concept determine the size trunking will be studied after this. And then this is some of accessory atau macam ni adalah accessory untuk 90 degree. You can see even 90 degree is bending, but nampak tu dia ada laluan. You have cable is more safety lah kan. Cable tu dia tak luka lah kalau dia lalu 90 degree, even 90 degree kan. So dia punya bending tu cantik lah, dia ada lengkuk tu kan. At the outside kita nampak macam 90 degree kan. So dia ada complete. So bila ada penyambungan, when we have a jointing for the trunking, you must put the copper earth strip lah. Ni yang ni. So when we have joint between two trunking, kita panjang kan. So bila kamu sambung, make sure you check. Kalau you install, you must make sure you install. Kalau you as a consultant, you pergi check ni, dia orang sambung tak sambung ni. Di antara dua trunking, ada tak earth strip. Kalau tak ada, you bagi NCR kat dia orang. Okay, capacity. So macam mana nak decide dia? So normally, dia pun ada konsep sama juga. And you just remember that it have space factor up to 45%. Dia tak boleh lebih 45% space factor dalam trunking tu. Kita masuk berapa banyak kabel, dia punya ruang kelegaan tu, space factor mesti ada 45 degree. Maksud dia setengah lah senang. Kan, jangan bubuh sampai penuh. Okay, so tukar klik, it also have some table lah. Tukar klik size trunking require some enclose of number of cable. Kita identify cable factor sama macam cable sama macam conduit tadi jugalah. So we multiply cable factor with number, then consider factor for trunking, and then we correct size lah, determine. So contoh macam ni lah. So table 5E is for trunking lah. So dia ada for solid and stranded. Kalau this is the size cable 1.5 to 1.5 up to 25 mm size. And then you need to check the cable factor based on type of cable. So kalau yang ni, this column ni, this column ni, this is for PVC, and this one for thermosetting, SFPE ke apa semua tu kan. So you refer this column. Okay. So kalau PVC biasa, you just refer this cable factor, this ruang ni lah. Okay. And this is trunking capacity size dia lah. So tadi dia just cable factor. So setiap cable dia ada factor dah. So based on that factor, macam conduit tadi kan. So we calculate, we multiply dengan bilangan cable, and then we dapatkan dia punya nilai. So barulah kita dah boleh dapat berapakah size trunking yang sesuai untuk our cable installation. So let's say we have this example kan. So kita ada 4 size cable kan that we want to put under trunking. So let's say we have 1.5, 2.5, 4 and 6. Dia ada lah. Kalau 1.5 and 2.5 dia jenis solid kan. Kalau kita tengok table ni pun sama lah, 1.5 and 2.5 dia jenis solid kan. Kemudian kalau lebih daripada tu normally stranded lah. Cuma bahagian ni lah yang awal-awal tu boleh beza. Okay. So kemudian first step we just multiply or we find the cable factor from the table 5E lah. So every size we determine the cable factor. Contoh macam 1.5, we can see from this table, dia punya cable factor adalah 8.0 kan, 11.9, sama yang 4, dia ada macam ni, and 6, 21.2. So kita dah dapat nilai tu, cable factor dia, senang lah. So kita just multiply je lah dengan number of quantity cable tu, berapa bilangan cable yang akan digunakan tu. So contoh macam, let's say for 1.5 mm, we have 20. So 20 multiply by the cable factor. So you just formula ni lah, factor multiply by number of cable. And then you just plus every type of cable. Sama lah. Net size is 25 kan. 25 dia punya factor dia adalah 11.9. You just multiply by number of cable. Then you total up, you sum up, and then you find out, let's say 1085.8. So based on that, you can find from the table 1085. So tengoklah kat sini. So based on your calculation, so 1085 kan. So 10, this one tak cukup. Nah, this one is enough, 1146. So based on that, you can determine that 75 multiply 36 size of trunking is suitable for use for your project. This requirement. Macam tu ya, senang. Kan? Okay, so another thing. So that one the settle for cable trunking, conduit trunking. So now we go to the cable tray, which is the last part of type installation before we entering on how to determine size cable. So cable tray is sheet steel channel with multiple hole, which is used extensively on large industrial and commercial installation for supporting MI and SWA cable. Okay, normally kabel yang besar kita letak tu. Kalau PVC kabel kita jarang kita gunakan untuk kabel tray ni. Okay, and then the tray should be bolt to bracket with round headed bolt and nut with the round head inside the tray so that cable drawn along the drawn are not damaged. So and then the tray is supplied with standard width from 50 to 900 mm and wide range of bend. 3 and reduce are available. So you can see this is sample of the cable tray lah. Kan? Nampak tu kabel yang besar-besar, laluan dia tu kita panggil dia ni cable tray. Kat office dekat lab pun kat koridor, you can go to koridor Unimed tu, you tengok kat atas, you nampak lah kat warna orange tu kan, kabel yang lalu kat atas itu adalah cable tray lah. Tadi trunking you dah kenal, this is the cable tray. Normally cable tray you just put kabel yang besar-besar lah. Okay. So settle on that and then now we go to the cable size calculation. Before that, is there anything that you want to ask me? Ada yang confused ke apa? Tak ada apa kan teori ya tadi tu. Okay, now cable size. So cable size ni you kena clear sebab under assignment 4 you need to perform cable sizing calculation for your project. Okay, and then you kena faham betul because during the presentation you need to present to us lah on how you determine the size of cable. Kalau kami tanya nanti make sure you boleh jawab. Okay, kita determine size cable based on apa? So satu, based on current rating of the cable under defined installation condition. And then number two, the maximum permitted drop in voltage as defined by regulation 525-01. So kita menggunakan dua ni, bergantung kepada dua benda ni untuk decide the size cable of our project. Okay, first based on cable rating. Bukan cable rating, current rating of design current tu. Kemudian number two is we perform atau we prove by the permitted voltage drop lah. So kalau voltage drop lepas, so barulah kita decide, okay, that cable is suitable for use. Okay, now, so how to calculate? So we calculate the size cable using this formula, which is this formula is coming from IEEE lah. Okay, you can open your book yang tebal tu, ada dalam buku tu. Dia punya formula ni. Kami copy pun daripada situ. So formula dia very simple. So IT is equal to IX. So IT ni lah kita nak cari. So IT is stimulated current for single circuit at ambient temperature of 30 degree. And then IX ni apa? So IX is depend. Dia kata refer table 5.1. You can open your area regulation. Dia tunjuk table 5.1 ada tak? Sini tak ada. So kat situ dia ada tunjuk table 5.1 ni actually we want to decide either we want to IN, the value IN we want to refer to IB or IN. Macam tu. So normally we use IN lah. Okay. IN protection current lah. And then we need to multiply by several number of correction factor, which is CA, CG, CI, CD, CC, CS and CB. Okay, so CA tu apa? CA is a correction factor for ambient temperature, CG for grouping conductor, CI for thermal insulation, CD is for cable buried direct the underground, CS correction factor for cable buried direct in the ground or underground conduit system BS EN 586-2-4 for soil thermal resistivity. And then CB, the rating factor for different depth of cable or ducting. Nampak tu. When you dealing with that type, so you must consider during for your calculation. Contoh, kan, your project is you want to install cable on thermal insulation, kan, dinding yang ada thermal insulation. So you must put the correction factor during your calculation. So normal engineer dia tak calculate benda-benda ni. So that's why the what we call it, the long life of the cable is tak sama based on manufacturer yang provide tu. Manufacturer dah buat elok lah, tapi based on the engineer's design of installation, dia tak provide a good calculation and they just directly install, so without consider all of the correction factor. So that's why the cable is not withstand with a long time. So you as a good engineer, so try to design with complete works lah. Okay. Okay, clear? So now we try to calculate lah sum. Sebab kalau kita ada formula, we tak try, so I believe most of you cannot understand on how to apply that formula lah. Okay. So let's say we have a single phase circuit to be wired in 70 degree PVC. Ayat dah, insulated and sheeted single core to BS 6004 having copper conductor dah. So the cable are to be installed in free air. About the free air kan kita ada macam-macam method reference method tu kan untuk installation. So yang ni for this question dia cakap dia nak install dalam free air. Free air ni normally cable tray lah. Istilah lainnya tu free air. Bukan free hair. Free hair tu orang perempuan tak pakai tudung kan. So yang ni dia adalah free air. Free air udara boleh masuk tu. Kan macam cable tray kamu nampak tadi kan, cable tray tu, so dia tak ada cover apa-apa. So dia punya air circulation lagi cantik lah, and then dia lebih sejuk berbanding dalam trunking ataupun conduit. And then flat space on cable support. Okay. And then given to us that design current is 135 ampere, and then ambient temperature 50 degree. And then dia bagi juga to be provided by BS88 2.2 jenis protection lah, circuit protection apa. So kita kena refer table tu untuk tentukan size IN tu lah. Itu tujuan dia bagi BS88 tu, maksudnya dia short circuit protection. Okay, maksud protection kan ada macam-macam jenis kan. So in this case provide using under the standard. So we will decide the IN based on IB and referring to this table after this. So based on that, dia tanya what is the minimum current rating for that fuse and minimum cross sectional size cable lah. Okay, so first kali we need to determine lah kan, formula dia IT equal to IX tu kan. So IX tu kita pakai IB ke IN? So normally we use IN. So formula IN apa? So IN is equal, IN must be greater than IB. Itu standard formula, kena ingat lah. So kita tahu we have 135 M for IB, so we must find IN which is much bigger than 135 lah. Then so we open table BS tu. BS apa bagi table BS88-2.2 tu. So we have 135M. So carilah yang berdekatan and above than that. So we only have this selection which is 160M lah. Because 100 is below than 135 kan. So IN confirm we need to select 160. Settle first part. IN dah dapat. So step 2 we consider formula IT equal to apa kan. So IN divide by CA yang ada banyak-banyak C lah. CI, CG, CD apa semua tu kan. So first we determine the table CA, ambient correction factor. So dia bagi ambient temperature is 50 degree. So we refer to the table 4B. Ada. So table 4B, siapa yang ada buku tu boleh buka, try buka. Sekejap. So macam ni table 4B. Saya try buka. Saya tunjuk table 4B. Ni. Okay, this is sample of ambient, nampak ah. Kalau siapa yang buku, ni buku orange punya, buku yang saya jual tu lah. Kamu boleh buka muka surat 176 ni, 174 lah. 175 this page. You can refer PVC, ambient temperature, tengok berapa kan. So dia bagi 50. So our correction factor is 0.71. Tengok asal ni. 0.71. Tu sebab tu dia dapat correction factor adalah untuk 50 degree is 0.71. Kemudian another thing dalam soalan bagi is grouping kan. Dia bagi grouping ayat dia tadi tu. So bila dia bagi grouping, mana ayat dia? Mana dia sebut? We provide what minimum kan dia tak bagi grouping. Tak bagi. Right. So kalau tak bagi, so kita bagi satu lah, anggap satu lah. Kan? So grouping dia tak bagi dalam soalan tu. So no grouping. So we assume CG satu and then the rest pun satu lah. Yang ada, we have only ambient only kan. So the rest we assume 1 lah. Kalau you assume kosong, you akan dapat IT equal to 0 pula kan. Salah lah. So we assume is 1. And then you calculate kan, you akan dapat IT is equal to 225.4. Okay. So based on that, we open again our books, page 177. So we have 225 Okay, 225. Yang ni single phase kan. Single, dia punya soalan adalah single phase circuit. So kita buka buku, kemudian open page 1, apa ni? Inilah 178 ni. Dan saya rotate jap. Single phase. Kemudian kita punya calculate tadi dapat apa? Lupa lah. 225, 225M. 225. And then 225M single phase. 225. Kemudian reference method tadi dia kata cable tray kan. So kita kena refer to this reference method which is method F lah. Can say in free air. Okay. So free air and then space. Dia ada perkataan space tadi kan. Space. Baca soalan balik. Kalau you confused, you just open back your ni. PVC about free air and then flat space tu. So flat space. So that's why we refer to space. Ini space. And then single phase lah. Okay, single phase of free space. Okay, horizontal ke vertical? Cari balik. Dia ada sebut horizontal. So horizontal, we refer to horizontal. Okay, this column. Okay, kita ada tadi, we calculate, kita dapat 200 apa? Lupa lagi. 281. Okay, 281. We must ngam-ngam lah dapat kan 281. Betul kita calculate dapat 281. Bukan 225. Okay, 225. 225. 225. We refer to this one. 225. Okay, 219 is not enough. So we must bigger than that. Kan? 225. So this ampere is suitable 281. So and from here we refer what size. So the size cable is 70 mm. So based on that we decide lah. Kita kata okay 70 mm is suitable with our requirement. Dah settle. Settle dapat size cable 70 mm. Tu je cara nak dapat size. Senang, sangat-sangat senang. Kan? So before this I believe that kita tak tahulah macam mana kita nak cari size cable kan. Okay, so now I hope you already understand the first part on how to determine the size cable. Okay, so this, okay, yang ni contoh lain lah, you boleh try sendiri. Okay, similar ni you can calculate by your own lah. Dekat hostel nanti you ada free you try buat sendiri, try calculate tengok ada masalah we discuss. Okay. Okay, now we go to the another second part, which is last part lah, which is we need to consider the voltage drop during the cable sizing. Kan? Tadi kita dah dapat size dia. Now we want to prove is it that size cable is suitable for our project. So we need to prove by the voltage drop. Okay, so voltage drop said that design engineer must have working knowledge of voltage drop calculation, not only to meet the relevant code, but also to ensure that voltage applied to the electrical appliance is maintained with proper limit. Most electrical appliances are designed to operate within a voltage tolerance plus minus 10%. Okay, so Malaysia utility supply regulation normally ensure the voltage variation at supply are kept within plus 10 minus 6%. So the IA regulation in Appendix 12 state that the voltage drop between the origin of iteration and end any point should be greater than a value in table 12. Okay, so we can see from this figure, this is from JKR. So they propose to us that it is between 4% from the MSB to the end point of the installation. Let's say your lighting of socket here, and from the sources of supply is MSB. TNB bagi kat sini kan. So from here to end of load, the total voltage drop must be 4% sahaja. So kalau lebih, so that meaning that cable size that proposed are not suitable anymore. So you kena increase of the size of the cable to one step lebih besar. Contohnya kabel tu 4 mm. So you calculate you got 4.1%. So that time you need to improve to the another one step lah. Kalau tadi 4, lepas 4, 6 kan. So you can propose 6%. So it depend to you for your project on how to distribute of the 4%. So this example from JKR lah. So JKR dia bagi macam ni. So 2% from MSB to SSB, and then from SSB to DB 1.5, and then from DB to endpoint is 0.5%. So this is just a guide for us, and for your project you can arrange lah. But total must be within 4%. So contoh you nak bagi MSB to SSB 0.5% saja boleh, tak ada masalah. That is depend on the designer. Okay, tapi you kena ada table macam ni untuk shows to your owner of the building on how you distribute of the 4% voltage drop. So dalam assignment 4 nanti kita nak tengok ada benda ni dalam you punya report, and based on this figure kita tengok you punya calculation, is it you meet your table yang you propose lah. Okay, so under cable size calculation, so this is some approach which is type cable, conductor cross-sectional, method, cable, road length, type of circuit, and load of circuit. So this is the formula that we use during the calculation of voltage drop. So for DC, so we use kalau DC lah, kan. So normally we use AC kan. Our project is AC lah. Kita tak main lah dengan DC ni. So we use this formula, which is voltage drop equal to tabulated MVAM multiply by IB multiply by length divide by 1000. Okay. Sama aja formula kalau voltage drop below 100 below 16 mm. Kalau 16 mm as I mentioned during lab session, dia ada satu saja kan. Sekejap saya tunjuk. Nampak saya sembang je apa kan nampak ni. Saya tunjuk terusnya. So contoh macam ni lah, let's say we decide tadi 70 mm kan. 70 mm size. And then you open the next space, is this related to the voltage drop cable. So 70 the size, and then you can see here it have a R, X and Z punya MVAM punya value. Ni yang value dia. Kalau 16 mm ke atas ke bawah, dia tak ada nilai R, X and Z tu, just only one. So you just directly use it. Cuma sometimes ada kawan-kawan confused lah. Cik bila ada 3 ni nak guna which one value. So you can use either you can use only Z ataupun you can use the formula kalau you tengok ni kan. Okay, kalau this one you just use Z saja, nilai Z saja. You can use this formula. Kalau condition is said that without power factor punya ni lah influence, dia tak ada influence by power factor. Okay, so you can use this formula directly. Kalau macam ni, you kena ambil bahagian Z saja, IZ tu, nilai Z kan. So this value katakan macam 70 kita dapat tadi. So nilai dia kita just ambil 0.72 lah, ambil bahagian Z saja. R and X tu kita abaikan. Itu contohnya lah. Okay, so IB design current yang awal tadi, kemudian length tu kita kena tahu lah berapa panjang saiz kabel kita. Okay, kemudian yang kedua formula dia adalah kalau condition which is melibatkan influence by power factor. So bila melibatkan power factor, kita kena consider power factor punya value lah. Formula sama sahaja. Cuma kalau you tengok ni dalam 4DC, this is formula 4DC. So IB length dengan cos theta, simple je. Tapi for AC, AC and DC lah. AC for 25 mm or greater, this is formula that you need to use. And if you can see here, tak nampak kot. So try to zoom it. Okay, nampak tak? Dia yang tabulated MVAM ni, kalau you can refer, this is value for R and this one is for X. Okay, this one already become cos theta and this one is become sin theta. Okay, and this one samalah IB and this one is line. You kena try lah, you try you buat nanti you akan dapat macam mana cara nak dapat yang betul-betul. So your project you must show on based on this formula on the calculation. Okay. Nah, contoh macam ni, kita ada satu contoh single phase. IB is 27, single core, 70 degree PVC. Not sheet, enclosed in conduit, 5 as a similar circuit. Okay. Protect against overload in short circuit by mean 30, dia dah bagi dah 30 MCB. So dia dah bagi ambient dia 40, length 38, power factor. So, bila dia bagi power factor, so confirm that we must use this formula lah, influence by power factor kan. So dalam projek kamu nanti kamu kena bagi tahu lah, either you want to calculate based on influence by power factor ataupun tak nanti. Okay, so kita try refer contoh ni lah. So contoh ni lah. Okay, kita ada IB 27M, 27M and then cable type is single core. And then protection 30M, dia dah tunjuk dah bagi siap. And then we have ambient temperature 40 degree, length and 0.8 pore factor. So firstly we find out the type of installation. Dia kata dalam conduit kan. Then protection 30M, and then okay, so we have from table 4B1. Yang ni kita tengok table tadi lah, table 4B1 tu. So kalau 40 degree kan, 40 degree, tengok balik 40 degree, ni 0.87 kan, 0.87. okay. And then dalam ni dia ada mention ada 6 group dengan 6 kabel kan, 6 kabel. Kat mana ada mention tadi? Saya ada perasan juga ada 6 tu. With 5 other similar circuit. So dengan circuit lain dalam satu tempat yang sama. So kamu kena tambah lagi 5, so sebab tu jadi 6. Okay. Kemudian so kita tahu kita ada group of 6. So based on that, we need to find correction factor for grouping, which is we refer to table 4C. So, rotate. So 4C yang ni lah. Kamu buka page 177 tu, you akan nampak C. So the grouping is 6 kan kat sini. So 6. So kita dapatlah table dia punya tu 0.57. Tadi nampak kan. So and the rest we assume satu lah. We assume 1. Sebab dia tak bagi kan yang lain other correction factor. So we calculate the IT. So 30 IN divide by CA and CG. So we will find out the 60.5 M. So based on 60.5 M, we refer to the table 4D1A. Tengok sini. Okay. Okay, kita tengok kat sini. Dia kata enclosed in conduit kan. Conduit, kemudian single phase. Single phase, kemudian dia punya value tadi kita calculate dapat 60.5. 60.5. Okay, 60.5. 57 tak cukup. So 76 lah kan. So kita dapat size dia adalah 16 is suitable for this condition. So itu yang first part. Okay. So settle first part and then we calculate voltage drop. So bila kita dah dapat tadi 16, we open to the next page of the cable which is for voltage drop table lah. For D1B, we refer to the 16 under reference method single phase. Method A, we can find that value for MVAM is 2.8. So directly, we can put it 2.8 here. And then 27 is a value of our IB, design current, yang dia dah bagi siap. 38 length, and then 0.8 is a power factor punya value. So divide by 1000. Strictly we can find 2.3 volt voltage drop. So after calculation, and then we try to this is value under volt value. So understand that it said 4%, so we need to convert 2.3 in unit percent. So divide by nominal supply. So kalau single phase 230 kan. So kalau 3 phase you kena divide by 400. So you calculate, you dapat only 1%. So 1% is below than 4%. So meaning that this per 16 size 16 mm size is acceptable to be used for your project. So after that complete on how to determine of size cable for your project. So that's all. So this is another example that you can use you can try to okay, you can try for your project, for your exercise lah. Okay, so I think that's all for today's class. So is it anything that you want to ask me? Okay dah, clear tak? Ada apa-apa yang tak faham tak? Okay ya, ni Muhammad Faris okey ya. Dia wakil nampak, kalau dia okey, yang lain semua okey lah. Sebab dia kan dia kan wakil nampak, wakil FTKE kan. Mewakili semua. Wakil kelas pun sama agak lah. Saya kena tanya dia. Kalau dia senyap, maksudnya hampa lain pun tak faham kak. Okay, ada apa-apa tak? Ni okey ni ya. Ni Faris. So kalau tak ada apa-apa, I think that's all for today. For tomorrow, I cannot make it lah. Kita tak ada kelas because I have joined the exhibition at KLCC. So sebab kita kelas face to face kan, so saya tak boleh pergi lah. Sebab sekarang pun saya dah sampai KL lah. So tunggu untuk for event exhibition tomorrow. So doakanlah tim kami, tim Unimed, tim FTKE lah berjaya untuk exhibition kali ni. Kita ada bawa beberapa produk untuk lawan di peringkat dunia lah. So kalau ada rezeki, adalah. Okay. So pray for us for tomorrow event. Okay. So, saya sedekahkan free kelas untuk esok lah. Tapi kalau kelas cek exam, maintain lah kelas cek exam. Kalau kelas cek exam, saya difahamkan dia orang nak buat tour. Dia nak pergi jalan, Cik Zan nak bawa jalan-jalan ke lab, nak tunjuk macam mana bentuk MSB, macam mana rail, kabel tray, conduit apa semua tu. Kalau nanti Cik Zan maklum saya jadi program tu, saya akan maklum dalam grup lah. So semua student saya pun saya izinkan untuk join kelas Cik Zan lah. Lebih baik macam tu daripada duduk saja kat bilik kan. So you pergi join sana. Okay, so that's all for today. Thank you. Terima kasih banyak-banyak. Jangan lupa isi attendance. Right, bye-bye. Assalamualaikum. Ya.
Nak present sekejap boleh tak? Nak tanya pasal drawing sikit.
Boleh. Okay.
Saya boleh nampak drawing tak?
Ya nampak.
Saya nak tanya pasal simbol switch ni. Tadi Kumaran ada tanya kan?
Ya.
So anggap yang ni semua soket biasa?
Kalau dia dah jumpa tak yang aircon-nya?
Aircon-nya tak ada.
You pergi bilik. You pergi bilik pensyarah. Bilik yang ujung-ujungnya. Okey, zoom itu.
Ni.
Tu dia ada label AC kan. So yang tu je lah. You punya split unit yang tu je. You cari yang ada label macam tu. Yang lain you assume yang tu soket biasa.
Oh yang ni macam ni semua soket biasa?
Soket biasa lah sebab kita tak ada legend tu. Legend tu hilang. Saya pun tak dapat cari balik.
Yang shade merah pun anggap soket biasa kan, betul?
Soket biasa.
Yang ni contoh essential kan? Kena ada UPS backup kan?
Tapi kita tak provide dalam design kita. So kita calculate soket biasa saja. So labeling tu you kena double check balik lah nanti. You tak boleh follow label dia lah. Sebab kan. Kalau you boleh follow, tak ada masalah lah. Kan? P1, P2, P3 tu mungkin saya rasa dia punya DB dia ada 3. Sebab tu dia ada P1 R1 kan. P2 macam tu. Dia pecah 3 DB.
Doktor, yang contoh yang DB tu short form dia kami tak faham kan. Kami delete buang tu letak susun sendiri DB tak apa.
Boleh yang ni hamba faham lah projek hamba.
Okey.
Okey. Yang lain. Ada yang lain. You boleh siap tu. Okey dah tu. Faham dah boleh buat lah. So yang penting you dah label tu you tarik masuk dalam Excel semua. You susun nanti. Baru you boleh buat balancing kan. You asingkan soket biasa, you asingkan aircon, you buat balancing elok.
Okay, Doktor. Thank you.
Right.
Terima kasih doktor.
Okay, semua. Okay.